Hi friends, so now we are going to talk about the storage services. So let's begin. So as we know that we all need some storage services within our applications to store some static data or maybe some messages, some files. So there are few types of storage services which are provided by Azure for different use cases. So we are going to discuss those. One thing to mention here is that these storage services, so they are geo redundant, which means whatever data we store in this Azure storage services is replicated. It can be replicated within two different physical servers in the same data center, or maybe different data centers within Azure zone, maybe different Azure zones within mm, a single Azure region, or maybe across Azure regions. So that's why we call it as geo redundant. And the data, it also has the feature of encryption of data at runtime. So let's begin with the first type, and the first type is blob storage. So basically, blob storage stores large unstructured data, blobs of data, for example, any video file, any image, audio, text, or even virtual hard drive files for VMs. Uh, blob storage can store various type of blobs. So I'll just explain them. So the first one is page blobs. So basically, page blobs are used for random read and write operations, maybe to store a virtual hard drive. Then there comes block blobs. Block blobs are used for uploading large amounts of data, which can be large video files. Then is append blobs. Append blobs are basically optimized for append operations. Maybe they are operational logs or application logs, right? So all these things can be stored in the blob storage. Next is the table storage. So basically, table storage is used to store the NoSQL or a key value type of data. So it's a, you can say it as a fast NoSQL key value store. Third is a queue storage. So basically, queue storage actually serves as a queue, and it stores a small size of messages of data, and it can serve as a purpose to for communication between two applications, wherein one application is the uh, publisher of the message and other is the subscriber, and queue storage can be a middleware messaging layer. Then is the file storage. So basically, storage is used as a drive to share files, and it uses server message block, or we say SMB protocol, and it can be used on Windows and Linux platform, and it can be accessed from either cloud or maybe on premises systems whenever there exists a path to Azure. Because the thing is that Azure files, SMB shares are blocked from internet. So there needs a path to the Azure from on premises. Next is a disk storage. So disk storage has more or less like file storage only, but they are meant for high I/O performance. So one example can be that it can be used as a drive in a VM, which requires high performance to run SQL Server. So all these are infrastructure as a service offering by Azure, except the last one which I am going to talk about, which is Azure Data Lake Storage. So this is a platform as a service offering, and it is like a huge data storage wherein user can store or dump any kind of unstructured data of various types and performance, and it can be later used for some analytics. Now we are going to talk about a few of the database services which are provided by Azure. So let's begin on that. The first one we are going to talk about is our Azure SQL database. What are these? So let's so basically Azure SQL database is more or less like a MS SQL server we use on premises applications. So basically these are Azure SQL database is fully managed and controlled by Azure, right? And it has all the features which are available in MS SQL Server, and it also has few of the good features which I'd like to talk about. So yeah, it is a relational database, but the good features are that it is automatically backed up, it is scalable, it has a SLA of 99.99% uptime, which is guaranteed by Azure. The data is geo-replicated. There is dynamic data masking, and there is a feature of transparent data encryption, which means it protects data at rest from unauthorized offline access, and the data is always encrypted. So you can store and query encrypted data within the database. And it also protects sensitive data by encrypting it in the client side. Next is the Azure Database Management instance. So consider an example that you are using some SQL database, which can be PostgreSQL or MySQL, and now you want to migrate to Azure. And there are few features in those specific databases which you use on premises which are missing in Azure SQL database. Then what do you do? Then you can go for Azure Database Managed Instances. So Azure provides this DB managed instances for PostgreSQL, for MySQL, MariaDB. So you can go with that and avail those features which you are using when you are on premises database. Then is the Azure Cosmos DB. So basically, Azure Cosmos DB is a very fast and flexible NoSQL database which is built for cloud native applications. It is extremely fast, and it provides guaranteed availability and speed at any scale with an SLA of 99.999%, right? And it also provides less than 10 milliseconds latency on read and write. Has got open APIs for MongoDB, Cassandra, Graph Data, and Core SQL API with SDKs for .NET, Java, Node.js, and Python. The data within Cosmos DB is also geo-replicated. It provides automatic indexing of data, and the good thing is that it provides all the 5 data consistency levels, which is like strong consistency up till eventual consistent. So the 5 consistency levels, as we know, are strong, bounded stillness, session consistent prefix, and then at last comes eventual consistency. So it provides all these 5 data consistency levels. So now let's shift our focus to the message service, right? So in the world of microservices, we know that we need to decouple our applications, our microservices. So we need some messaging layer in between so that our services can talk to each other. So Azure provides very good solution for that in terms of first we'll see Azure Service Bus. So basically, as I told that it is used for decoupling the microservices via persistent messaging layer. It comes in two formats: Azure Service Bus for queue and Azure Service Bus for topic. The difference is when we use Azure Service Bus for queue, there can be multiple publishers which are pushing the message over a queue, and there can be one or more subscribers also, but the key part is that that message will eventually be processed by only one subscriber. In Azure Service Bus topic, it's more like a pub sub wherein there can be multiple publishers publishing the message to a topic, and there can be one or more subscribers, and each subscriber is going to receive a copy of that message to get processed. Next one is Azure Event Hubs. So these are meant to capture massive amount of data, maybe to analyze or to for transformation. When I say massive amount of data, I meant to say millions of messages per second. The best use case is suppose we need to capture the signals from the IoT devices. So you can go for Azure Event Hub, and it retains messages up to 7 days. And also it has the feature, if you want to indefinitely retain those messages, then it has a feature of events are capture free, where we can write those messages to a data store also to persist it indefinitely. And yeah, it can be used to query data also. Next is Azure Event Grid. So again, it is a fully managed PubSub service that can be integrated with many Azure services or even custom publishers and subscribers. So when I say it is a PubSub, then how it is different from Azure Service Bus topic, which I just talked about. So basically the thing is that when we use Azure Event Grid, then it uses the push mechanism to send the messages to the subscribers. So what I meant by that is that there will be multiple publishers publishing the message to the event grid, and there can be multiple subscribers also. But it is a responsibility of Azure Event Grid to push those messages to all the subscribers. It is whereas in case of Azure Service Bus topic, it is a responsibility of the subscribers to pull the message from the topic. So that leads to a higher latency, wherein as in Azure Event Grid, the latency is lower and it can be used for reactive applications. So next we are going to talk about a few of the security services also. So let's begin with Azure Active Directory. So basically Azure Active Directory is similar to the Microsoft Active Directory which we use on premises, right? And it is used to manage identities for authentication and store users profile. Next one is Azure Keyword. So basically Azure Keyword securely stores and manages various confidential data, which can be application certificates, which can be keys and other secrets like passwords and all. So how it helps is, suppose I'll give a use case. So suppose I have an application which needs to talk to a database, and database will have a password to access it. So I don't want to configure that password or write that password in the code or in any configuration file. No. So what I can do is I can store that password in the Azure Keyword, and my service or my application which wants to connect to the database will be registered as a service principal in Azure Active Directory. So in order to get the password, so first my application is going to request for a token from Azure Active Directory. Azure Active Directory will validate that application, and it's going to provide a token to that application. So that application now is going to send that token to the Azure keyword requesting for the password. So Azure keyword will validate that token, and it's going to return the password to the application, and then my application using that password can connect to the database. So apart from that, there is Azure Web Application Firewall, right? So it is a managed cloud native service that provides powerful protection for web apps. It can protect from malicious attacks, web vulnerabilities like SQL injection, cross-site scripting, and whenever it detects any malicious attack, it blocks them from reaching our application. Next is Azure Front Door. So basically, Azure Front Door, you can consider it as a global scalable entry point to create fast, secure, and scalable web applications. Because it also provides a load balancing feature, it reduces latency, it increases the throughput, and then it also provides the modern content delivery network, which is CDN functionality also. Thereby, it reduces the latency to a great extent. And now, why I'm calling it as a why I'm mentioning this in the security services, because it also protects against network application layer attacks at the edge server only with the web application file. So it can prevent DDoS attacks as well. Then comes Azure API management. So basically, it helps us to create the API gateways for existing backend services. Therefore, it provides security. It can prevent OS attacks like DDoS, etc. And so in a way it secures the backend microservices, and it can say also be used that API gateway for JWT tokens authentication. All these security implementations we can implement at a one place, which is that API gateway, so that our backend services are more secure, because API gateway is the one which is exposed to the outside world. The request first hits the API. Next is the Azure Application Gateway. So basically, this is like also a kind of it's we can protect our various microservices behind the application gateway, because it offers layer 7 load balancing, right? So what happens is we can it has the, what should I say, the layer 7 routing capabilities, wherein it's going to route the request based on the round robin distribution for all the incoming web traffic. It can be used for cookie based session affinity, URL path based routing also, right? So basically it gives us the ability to host multiple web applications and APIs behind a single gateway. Then comes Azure Load Balancer and Azure Traffic Manager. We know what our load balancer does, but how Traffic Manager is different from load balancer is that it provides the DNS level routing of the request, wherein it will route the request to the nearest data center where the application server is there, and it's closest to the origin of the request. So it helps in reducing the latency to a very good extent. So CDN, as we talked about, content delivery network solution provided by Azure, which can be used to store the static data or any cache data. Therefore, it reduces the latency, wherein the request will get those files and data from the edge server itself, rather than that request coming all the way to the application server. Then few of the caching services, Azure Redis Cache, which is as a managed Redis cache platform provided by the Azure. So yeah, friends. So that was an overview of various, not if not all, then many useful components and services of Microsoft Azure, which it provides, and we can use them to solve our problem statements of our um, applications, our complete system based on what fits best for what use case. So next, I'll deep dive into each and every my services or components which I explained, and I will demonstrate them on how to create them using Azure platform via Azure portal or via Azure CLI or PowerShell or via ARM templates. And then I will also integrate those services with some custom applications. So stay tuned. Thanks a lot and have a good day.